Okay, so hi everybody. So in today's technical steering team meeting, we're going to discuss some ideas and sort of plan for supporting federated control domains, and Madan's going to lead a discussion. We also have visitors from Italy attending remotely. Well, and also some in person too. But before we dive into that, first let's go to our standing item, which is for community acknowledgements. And so, Dave, you said you added a few.
Yes, thanks for making space for this. Again, the idea is just if we bake recognition of moments into standing processes, that will keep it top of mind for everybody. And so I this week wanted to give a shout out to Ayaka and Bree for helping us optimize the documentation contribution information. And this page is linked to from the Technical Steering Committee wiki, and if you want to just remember to thank somebody in the community who's done something worth recognizing, please just add it, and then every time we have these standing meetings, we'll just have a chance to give that shout out.
Great. Thanks, David, and thank you, Ayaka and Bree. Oh, Bree's not here, but I'm sure. All right. So I think with that, we can probably turn it over to Madan,
sure.
And we'll start the things rolling.
So yeah, I'll just use this. So yeah, we are going to talk about federated control support in ONOS. And before we go into some of the details, I wanted to lay out some definitions so that when I say some of these terms, we know what we are talking about and we are all on the same page, right? So the first definition that I would like to introduce is the notion of a control domain. This is something that we are all familiar with, and so basically the idea is that you have a network that is managed by a single ONOS controller cluster. This constitutes a unit of control, a network that is controlled by this cluster, and decisions over what flows are provisioned, how they are maintained, and everything. The autonomy for those decisions lies with this particular controller cluster. And the way someone would provision network connectivity in this network is by submitting intents, basically using the northbound APIs, intents, flow objectives, and interacting with the controller cluster to do that. So that's the definition of a control domain. You'll keep hearing this again and again, but this is what I mean by that. The next definition that I would like to introduce, again, this is not something that I'm defining, but this is a construct that we have been talking about. This is, I want everyone to focus on this, because if you clearly understand what this is, then when we actually go to federated control and all that, I think hopefully it will make good sense how we can take the concepts that are defined here and apply them to a federated distributed network structure. So the idea is that here we are still within a single control domain. So you have a single ONOS controller cluster that is managing a network. The idea is that you have a network that is made up of different segments, and these are identified as these inner dotted circles that we have. So each of this network segment or domain has a topology that is well suited to be managed by a given application. So let's say you have a piece of network which is which has a data center, leaf spine, fabric type topology. Maybe you have a segment routing application that is responsible for providing connectivity within that domain or segment of your network. Or perhaps the type of switches that make up a particular portion of your network are such that you require a different application to help provision connectivity in that portion of the network. Maybe you have an optical network in which the connectivity is established through a different application. So these domains or subdomains within your larger network are what we call intent domain. Okay. So the idea is that if you want connectivity within a given intent domain, that is the responsibility of the intent domain provider, someone who provides connectivity in that segment of the network. Okay. From the point of view of connectivity in the larger network, these individual intent domains are, you can view them as big switches, or essentially blobs that hide some of the inner details of how connectivity is established within that particular segment or or domain, right? So if you want to establish end-to-end connectivity in this network, what you do is you first identify a macro path that traverses or basically establishes connectivity from the between the two endpoints. Identify the different intent domains that this macro path traverses. So, at a high level, you establish the sequence of intent domains that you need to take to get from point A to point B, right? So, in this simple example, there is just a single macro path that is possible for these two end hosts. But you can easily imagine a network where you can have a set of paths. Again, these paths are at the level of intent domains that are possible in your network, right? So step one, you identify the macro path that you can take, and then step two, once you have identified those macro paths, request the individual intent domains to compute the cost estimate within that particular domain. So what you are trying to do is now trying to dig one level deeper into how a path can be computed within a given subdomain.
Kishas,
yeah.
Ask a question. Last one. So how can you compute the macro path without cost function?
So at a macro level, the idea is that you are just trying to see if you can get from one intent domain to another intent domain, right? You still haven't computed any cost there.
So assume there was intent domain 4, which form like a diamond shape. Should I go top or down? Unless there is some hint about cost, sort of cannot choose which path to go. I think.
So at least
yes, so that's correct. There's going to be so the interaction between the consumer is a big process.
But the thing is that also, like, between intent domains, you actually don't have links. That's the thing, right? You don't actually have the link between intent domains.
So
yeah, you can't, right? Because if you do, then who's controlling that?
There's a couple of different approaches to address it. They each have their caveats. We haven't made a necessarily decision yet. Right now we're leaning one specific way, that you have notional boundary devices, but you still have the same problem. Who controls the boundary device? But the idea here is that there's a macro topology.
No, so that I agree. That I have no hard time imagining. My point is like the problem with intent domains, the real crux of the problem is not like how do I define a domain. Is how do I control the boundary of that domain, and that is going to be like your complete, like, it's going to determine how you route through your network, how you do everything. Can you actually do it?
Sure.
For that matter. So that's where the problem lies, right? So, I mean, that's kind of
So
anyway.
in a way, this is not dissimilar to what you do today with autonomous systems already, right? And this is where probably gets at the origin of Yuta's questions. Is you need to have some notion of a. Notice that what we're computing here is not necessarily shortest path. We have a graph. We can produce paths through the graph, and we can also potentially even not necessarily shortest paths. And then it gives the consumer the ability to then choose potentially route through different. You have viability of multiple paths. They have different costs, but you can still choose between different alternatives. Very much like when I'm planning a trip to LA, I have a choice of taking a train, taking a car, and or just driving. Different characteristics, and I may decide to do different ones, not entirely based on cost. So there's some parallel.
The idea is to choose an appropriate path, not necessarily the shortest path. Or the shortest here is an abstract.
I think
least cost path.
Least cost.
I think
Whatever the cost.
yeah. Okay, so forget cost, but then the cost is not defined.
Yeah, how many then?
Right, then by what properties do you decide what path? I mean, something's you gotta make a decision. You can't just say I'll go this way.
I understand, but I don't think we need to solve that problem now.
No. I'm just saying.
Yes.
One thing that might just say one thing that might make things clearer. It seems that you started saying that you were going to just talk about definitions, but it seems that you've now presented a bunch of solutions without explanation of what the problem is that you're trying to solve.
So, well, I think only the control domain is the definition. Just so that that's a terminology that I wanted to have.
Yeah.
In
do you
place.
want to say the problem you're trying to solve? I mean, maybe just based on the solution that you've presented, I think the problem.
So this is not. I mean, we are not in the solution yet. I mean.
well, I mean, I think what you presented so far is this proposal for hierarchy and aggregation of routing, sort of divide and conquer, similar to what Murphy proposed, and it appears that so that's bottom up. You've produced this low-level sort of abstract design, so I'm trying to figure out, and it appears that that's sort of the design for your solution space. But the question is, what's the problem space to go with the solution space, right? So reverse engineering, I think the problem is figuring out how to provision end-to-end routes across a geographically distributed network.
So perhaps
Yeah.
what's
With
missing,
us.
okay, so perhaps what's missing is a little bit of background information, and that's something that we may not necessarily see as a lack of context, because the context exists in our heads. The intent domains is something that we plan to work on for other reasons than federation. It's basically is recognition that different parts of networks behave differently, and this is essentially a construct that will allow us to evolve the intent framework and to be able to host it on heterogeneous networks. Right now,
Okay, so
it's an existing construct that Madan is defining, but he wants to make sure the audience knows about this construct. Because it's going to, once one understands the construct, it's going to make it much easier to map into federation, see how it maps into federation. But that construct can exist entirely on its own, and is very useful in the context of intent subsystem alone, without any ties to anything else.
So if I understand you correctly, you're saying that the problem, that there was a problem of, well, maybe not a problem, but a situation where it appeared that provisioning different pieces of your network was appropriately modularized in having this sort of different, separated routing subsystems or applications.
Exactly.
And an abstraction for dealing with this, which you're working on, is intent domain.
Right.
Okay.
I think I probably went very quickly over that part. I mean, you have a piece of network with slightly different network topology or network design, and maybe different applications are better suited to providing.
Yeah, but that's one design which is not necessarily, which is also different than what we've historically been proposing, which is arguably better design, which is one routing system to rule them all, something which actually understands the characteristics of lots of different kinds of networking hardware and can intelligently globally optimize things. This proposal simplifies things but also hides information. So it's, there's a serious trade-off there between like complexity of your routing application and sort of optimal behavior. And so this is one approach, but it's not necessarily the right approach or the best approach. Although I gather it is an approach you were working on and moving forward with.
Yes.
Yes.
That's the latter is the case.
And there's other issues like Ali mentioned. Also.
No, I'm not saying everything is worked out. No, that it's without
so that's a proposal that it seems to be needed to be worked out on its own as well.
But intent domain is an abstraction for basically that can be overlaid on top of a segment of a network which has some common characteristics. Let's say it's an optical network, packet network, or or a bit more specific, like a network that's it's with segment routing operating on a or other characteristics, and then you can ask it to do things, and it has a way of knowing how to best achieve those things. Certain sets of parameters.
And so right now you're not actually, you haven't stated your problem yet. You're just explaining how the existing intent domain system that you're developing is going to work or does work.
So
I have a,
yeah, I think there is
just for the
in one of
conversation
the
that we
Although I don't think it works yet
Slides.
because it seems there are logical issues that haven't been solved yet.
so there are still some open
Every
issues
type
that
of
need to be solved in this
as a library
in this
language.
case, right?
Yeah, yeah.
But the idea is that
Problem.
once we solve those issues, there is a nice way in which this solution can extend to a model in which you have geographically distributed control clusters.
And yeah, we're not denying the challenges that are there, but I think they're unsurmountable.
Okay, well that gives me enough context to actually try to understand what you're proposing or what you're about to propose.
Okay, sounds good.
So, any questions before we? Okay. So, I think some of this is hopefully intuitive in the sense that once you identify, the different macro paths, what I call them as macro paths, which are connectivity at the level of intent domains, and then also get a sense for the cost of traversing a given intent domain. That gives you an opportunity to you have a set of paths and the associated cost, and depending on whatever selection criteria you use, basically pick an appropriate path. And once you have chosen that, now you are asking each individual intent domain to provision that path within its segment. So you have, say for example, a segment routing application that is responsible for connectivity within intent domain 2. You ask that application to provision connectivity for this path for the segment that traverses its domain. So that's the idea behind, like, how do you compute a path, how do you select a path, and how do you provision a path. And that's part of the problem, right? Once you establish a path, how do you make sure that path is maintained, as things change in the network. Here, even the idea is, if a failure is contained within an intent domain, in the sense that the failure only affects connectivity within the domain, then it is the responsibility of the intent domain to deal with that locally. It doesn't have to involve the parent controller to deal with that particular problem. I mean, there are reasons why the intent domain controller might sort of expose some information to the parent controller, especially if you want to do global optimization and things like that. But for dealing with path failure or repair issues, some of these failures can be handled purely locally. So that's the idea here. Now, if you have failures which affects your connectivity across domain boundaries, so if there is no way for you to go from intent domain 1 to 2 because of a failure, those kind of failures need to be surfaced up to the parent. Now you need greater context to do something about this particular failure, and that is the idea here as well. So a failure happens here, you cannot deal with it locally, so now you surface that failure to the parent controller, and then appropriate action needs to be taken over there. Sorry. So I think with that explained, now we are at a point where we can actually get to the problem that we want to solve here, right? So you have a set of control domains. Again, control domain is what I defined earlier. A piece of network that is managed by a separate controller cluster, and you want to interconnect these two control domains. You want to provision flows that cross the domain boundaries. Go from one domain to another domain and so on. Now, how do you solve a problem like that, right? So if you draw the picture slightly differently by hiding some of the details, so what you have is each control domain is internally made up of multiple intent domains. So connectivity within the control domain, is essentially delegated to those individual intent domains. And a picture that emerges is a picture that is more hierarchical in nature, right? So now that we know what an intent domain is and what we want to achieve, the way to look at this picture is that each control domain, which is the one that you want to connect with another control domain, that is represented as an intent domain from the perspective of a parent controller, which is now responsible for orchestrating connectivity across these two control domains, right? So when you want to establish connectivity, from a flow that basically goes from domain A to domain B, it is just like how you would have done if control domain A was an intent domain, right? So a request to provision path in that control domain gets submitted as an intent to that particular subdomain, and the logic is similar to how you would do if it was an intent domain. So this is the primary crux of the solution here. So what you have is a model that is composed of intent domains, and this is something that can be built in a hierarchical fashion. There is no reason to stop at one level. If you have, if you want to, build connectivity across geographically dispersed locations. Say, for example, you want to establish connectivity across continents. You could imagine, within a country you have a setup like this, and and setups, each individual country setups essentially connected through a parent controller. The logic stays the same, the abstraction stays the same. So that is how you would extend this model to a larger and larger network.
Seems that the control logic will change though, because in a data center you might be sending probe packets, and if things take longer than 10 milliseconds to make it from one end to the other, things are wrong and you want to reroute. Whereas, and from the East Coast to the West Coast, the timeouts are going to be different from large geography. So there's a lot of, I guess, timing dependent behavior, and somehow that information needs to be exposed to the control logic, and the control logic needs to be aware of it and to understand it in many cases.
Sure, but I'm not sure whether necessarily those level of detail. So it needs to be exposed because even Murphy recognizes, right, in his proposal that there may not necessarily be symmetry with the leaves and the controllers, even though the original proposition was that it's just hierarchical and that basically just each control domain is basically a big switch. But then he recognized later that there's asymmetry there. And maybe that asymmetry extends and continues into the upper layers. But I think that it lies somewhere in between. There may be asymmetry with the leaves, but then from that point onward, above, it can remain symmetric. And the reason I think the intent domain maps nicely into federation, where first of all it deals with connectivity, concerns,
solve that.
and the control interactions between to and fro, across the intent domain boundary is in high-level constructs, which is these basically connectivity or high-level primitives, primitives from which intents will be built. And because they're high-level objectives that are more concerned with what should get done rather than how it should get done, they lend themselves to be conveyed over potentially stateless channels like REST APIs or things like that. They're not predicated on high-frequency interactions like the rest of the system, unlike the rest of the east-west communications within the control cluster. And so this should scale reasonably well, and plus also the coarse nature of the interactions should also lend itself to security checks, which will be required in order to have control domains that fall under two different authorities.
Well, that's not going to happen, man. So like the fact that I think we need to scope this problem. I think federation is extremely valuable and clearly desirable, but like this notion that we're going to have federation across autonomous systems and administrative areas, that's never going to happen. It's just for political reasons, it just never happens.
Yeah. So Lee's making a really interesting argument, which is that a hierarchical federation may not make sense for political reasons, and so like a more peer-to-peer kind of thing where there's negotiation.
Right.
Sure.
might
No,
be-
it's so-
There's that mode. There's that mode which we have to recognize is like I think like the assumption that like we tell two administrative areas to say now you have an Uber master.
Yep.
Is like I mean everybody will say like yeah whatever no way. But the thing is
well, not necessarily.
It's not Uber Master.
If we purchase slices from them, then
no, that's the thing else,
Yeah.
right? So, but within a corporation, say within a corporation that has offices across the world,
Right.
yeah, totally valid.
Do you, I mean, you interact with Expedia or Kayak or whatever, right?
Yeah.
All right. Well, this is the same.
It's not the same
No
thing.
question.
No.
No, I mean, this
Not the same.
maps perfectly. I mean, I don't know whether it maps to companies like AT&T and Verizon doing their thing between each other, but I know that this maps extremely well to like research networks or ES, like ES.
Oh, absolutely.
Where you have basically
Absolutely.
different authorities, different control domains. They have needs to shuffle. Huge problems shuffling data back and forth.
So this much I agree with. That's what I'm saying. Like if you have like Coca-Cola that has offices around the world, then yes, this model works.
Right.
But you have to recognize that like if you take it to the scale of a country, right, or you have different ISPs, right, who are all competing against each other, right, none of them.
I don't think
So
that's what we're aiming for.
I think
So we have to
one
scope
thing-
it, right?
Yeah, exactly. I
Yeah,
think
scope
maybe this is I was missing this slide. I think I discussed this with Thomas, but we want to scope the problem here. We are not talking about like redesigning the internet and then saying that this is the model that will apply to we will rewrite like the whole
Well, I guess
AS.
the question is, what problem are you trying to solve?
Right.
So let's take the example of essentially this is a model that will apply to control domains that want to collaborate with each other.
Yes.
Okay.
That's fine,
So not compete with each other. I mean, there is a trust boundary that sort of encompasses these things, and it's not like we are like these guys are trying to win at the expense of each other. That is not the case.
And also, even though what was portrayed here is a hierarchical model, you can remap the hierarchical model to essentially a peer-based model, but clearly with implied scalability limitations. Because if you have small number of control domains, then they can arrange things peer-to-peer with each other. But there's clearly limits to that because all of those n squared, right?
Well,
the number of meshes.
maybe I mean
But
BGP
it's
is kind
perfectly
of peer-to-peer also.
Yeah, BGP. So from that perspective, like the peer-to-peer model works well, right? As in like BGP for internet scale.
If it follows lines of adjacencies, yes, but okay, sure. So
Again,
my point here is that this does not what Madan proposed does not preclude peer-to-peer relationships.
No,
It's like the same tactical
No, that's fine.
implementation can be just simply you turn it into reciprocal relationship.
I think the selling point for something like this is to make it possible for universities or even research environments and corporations to spin up equivalents of layer 2 or layer 3 VPNs across their networks. Across their networks in a very flexible way with
Exactly.
like simple meshes.
Yes,
So
exactly.
that's the
Yes.
valid. That's what we're saying, right?
Yes, that's exactly.
And I think scoping this problem and defining it in those terms is fundamental to its success. Because if anyone feels like we're trying to redesign the way we peer across the internet,
No.
or we're trying to
No.
redesign the internet, people will immediately shoot it down.
No,
Okay.
okay.
That is not what you're proposing. So
Okay,
that is
I think
That's
we're
something
in
that's-
complete agreement. I think
Okay,
we
that's
just
good.
probably just didn't articulate that.
yeah.
I would argue that if you can demonstrate a better way of peering,
Sure,
on the
that's a
internet,
separate problem.
then that might be very compelling.
Sure.
And a way of peering between SDN networks that was perhaps better than BGP and allowed you to make more globally optimal routing decisions and had better incentives and maybe even a better business model. I mean, if you might be able to do something better.
There's nothing better than BGP, man. What are you talking about?
Okay, so I think we're in agreement. So I definitely agree that it needs to be scoped appropriately.
Yeah.
But you do agree that for
Oh no, I totally agree.
Okay,
No, I
great.
totally agree. I mean, we tried to do this exactly this with Genie and FlowVisor years, and in Genie it never worked. But like, well, it works, but not really.
Yeah, I mean, we've seen the needs to the. I mean, there's pressing needs to do this, right? The research organization. I mean, I was at the Lawrence Berkeley deploying SDN symposium in the summer, and use cases that
but even
left and right.
Even the grid at CERN, they use SDN to disseminate data, right? Right now, they're doing it today. But like, if they had something like a federated controller, which allows them to spin up capacity in different areas, they'd be all into it.
Yeah. Okay. And so the thing is with okay, I'll let you continue. Sorry.
So I guess I mean this is almost all the prepared material that I had, but so the idea is, I mean, just to sort of provide a little bit more detail on how, I think picture is well and good, but ultimately it has to be implemented. So just to provide a little bit more detail on how this interaction would occur between the child controller and the parent controller. So the idea is that the child controller exposes certain events to the parent controller, and these events could be a curated set of topology events. I mean, not the entire topology, but those the necessary information that is required, to be able to sort of reason about what is connected to where and so on. And this could also be events around, by the way, this thing that you previously requested me to provision, that is broken now. You need to do something else. So these are asynchronous notifications that go from the child to the parent. On the parent side, the entire control domain is, basically represented as a big switch, right? With the appropriate edge ports that basically show you how it is connected to other control domains. And it is also encapsulated as an intent domain. So there is an intent domain interface. So as I said, the control domain is represented as an intent domain at the parent level, and whenever you are making connectivity requests, those get translated into specific intent requests that go to the child controller. So the APIs on the parent as well as the child for connectivity and flow provisioning are exactly the same. So the advantage is that this provides you there is the APIs are the same whether you are working on in the child or in the parent.
One little thing. Yeah. So one little thing. So logically, this part completely makes sense for me, and especially, and the arrow going down probably will work completely fine on the distributed context. The arrow going up potentially is a bit of a concern. The thing is that mostly abstract as a big switch, it might be okay, but the one moment in time within this lower cluster, there is no agreed topology. So if we need to deal with HA there, now which event do we need to push it up to the controller? That's sort of a question we probably need to.
Or if you have multiple peers, right? And you have agreements with multiple peers about delivering certain things, then you may need to actually send messages of quote-unquote broadcast the events to more than one parent because you have multiple peers. So those things definitely have to be addressed.
I think there's also a bit of missing stuff here as well, because when you have this connectivity request, like, you're going to need to know information in order to make that connectivity request. Like, in particular, even with the big switch model, between two ports on this big switch, I would like to know what kind of bandwidth I can get between them, what the latency is, and like what the cost, what other cost metrics might be.
And this is where the bidding process comes in, where basically you make a request, you get back a series of offers, you pick from the offers, and then you basically select that offer and request that.
There's a feedback.
There's a feedback to that.
So I think the idea is to, I think the way the parent would interact with the child is like at least there are two things, right? I mean, one is, give me or show me the cost estimates for this path. That would be, a synchronous request that the parent makes to the child. And once it selects a path, I want you to provision this particular path that you previously said is possible, right? At this cost. So there are multiple individual request types that go in the bottom direction. The idea is that they're all synchronous requests that come from the parent to the child. The ones going from the child to the parent are asynchronous in nature, notifying of topology changes or previous connectivity or connectivity issues and so on.
I always use sort of this trouble website type or trouble service, a metaphor.
Yeah, I think it's a good one.
used, but it's like you've selected your flight from a list of possible flights, the one that leaves the right time of day or is the right price or whatever, or flies with the right airline. But then later on you may get notified that that flight's been delayed for 30 minutes or change gate. Right? And so that's the sort of model that.
I think I like that metaphor actually. I think it makes it a lot easier to understand.
Madan, so the quick question. So for the parent control control domains, the child sends the topology to the control domain, the parent. No.
Well, not the entire topology.
It's just
Obviously.
the edge port.
Right, just the edge.
Port. Okay.
Just the elements that the other needs to see.
Yeah. Do you consider the multipass between the child? Multiple paths. You have the multiple paths.
Right.
Yeah. Do you when in your
So if two control domains are connected to each other using more than one link.
Yeah. It's the multiple paths. Yeah. Multiple links. So currently is one link. Once it's done, your entire network is done, right?
Right.
End to end is done. So then normally they will guarantee that you'll use the multiple paths, multiple links.
Mm-hmm.
So when the multiple links is introduced to for this case, I'm seeing if my memory is correct, go back to your previous ones. You're saying you have two node failure mode. The one is the edge mode, right?
Mm-hmm.
Another is the internal mode.
Mm-hmm.
Actually, in the multi-pass case, this internal mode could change the cost of from ones, right?
Sure.
So that will cause the notifications need to be sent to the parents, right?
True.
Yeah. So in the beginning, you said the first case, you don't need the
So I think there is a reactive component to this. When something fails, obviously you want to fix, at least put in a temporary fix.
Yeah.
Right?
Yeah.
And that might actually not be an ideal fix, but at least it keeps your customers happy for the time being, right?
I mean, and the thing is, if it's a if it's a failure that's on the inside of the domain that can be cured, but let's say they overbooked the passenger cabin and economy, so we're gonna have to bump you up to first class. Well, there should be no change in cost.
Oh yeah.
Right? And but if for example they get moved from the first class to the economy, they should probably get notified because you reserved a certain bandwidth or latency and you're no longer getting it, so you need to be notified.
Yeah, the service degradation notification.
Yeah, exactly.
Service unavailable or degradation.
Right.
Yeah.
And similarly to your question, I think your question was more tailored for multiple paths within the intradomain. But also there's clearly the model allows for multiple interconnections between the two same domains. There can be multiple linkages.
I think that when the multiple paths, the interdomain multiple paths is considered, so the more notification, more scenarios need to be covered by your algorithm.
Yeah, I think this is the detail that we obviously want to focus on, right? Because again, we are just taking this model and then
But like one thing that follows from Patrick's, what Patrick is saying, I think, is that you might want to be able to specify a fast failover to an alternate exterior path, right? Where like, if this guy fails, I want you to immediately start accepting like packets from this other port because I want to basically automatic failover to different paths.
Yeah, but it's the FR features in the current network is the common.
So provisioning, I can imagine lots of things you might want to specify. You might want to specify like separate failure domains for different paths and things like that.
And so there's sort of the sharing page or the sort of offer accepted dialogue that's is being introduced into domain. as a mechanism to cure some of the ills of the current intent framework. I think it maps really well to this. And it also allows us to, in a sense, we're talking about things not about here and now, but also in the future. This is where you can some do, calendaring of bandwidth or things to request like that.
To the one thing is the one question. One more question is not related to your algorithms. It's about the implementations. For the implementations, you can use the current intent framework to handle this, right? So the more and more computing power is required, right? When the multiple pass scenarios is covered, is considered. So do you have estimations about how much the computing power do you need by the certain size of a network? Let's just do some estimations.
Does that matter? I mean, you can just add ONOS instance and you have more compute resource.
No, you can't. This computing powers for the past that's based on this. So you think about it, it's the one domain. So basically, once you calculate the path based on our current intent implementations, only the one instance is involved to calculate the path, right?
Okay.
Right. So you can't use them even though you extend the multiple instance. You cannot use that the computing powers. So the same things is here. You are trying to do the hierarchy stuff.
Sure. So you do get you actually do get a performance increase when you add more instances, because for the intents, yes, the intents are compiled on one instance, but the installation is on multiple instances.
Yeah. But just as a side comment, CPU is not the scarce resource that we have. It's memory and I/O.
Even memory.
It's mostly I/O.
It's I/O and network resources.
Yeah.
Device.
Well, that's what I was talking about. I/O. I was talking about this I/O, right? But it's but then we have SSDs.
We have a lot of memory.
So it's really. I'm not terribly concerned about the CPU here, and I think even if we have terribly inefficient path finding algorithms, we have still plenty of headroom.
Yeah.
And also, I mean, if you're talking about the fact that I mentioned there is a multi-step process before we can identify a path and then provision it, versus previously, the path computation was local because we had the global network view, which is at the level of switches.
Yes.
I mean, one alternative is these intent domains. There is nothing stopping them from pre-provisioning tunnels, and when a new request comes in, all it says is basically, I already have it.
Okay.
Right. So there is no need for it to do path computation and all that. So that is something that that will most likely happen on some of these smaller domains.
Also, we're not dealing necessarily with more path computing, even though there will be more paths being computed. They're not end to end. There's smaller sections. So it's a problem is subdivided too. So I don't think it will necessarily take that much more computing power.
Yeah. And also the subpaths are computed in parallel.
Yes. Exactly.
Okay.
The communication between the parent and the child domains are completely
what is the protocol that we use? I mean, these are, you can think of, there is an application running on the child and the peer application running on the parent, and this is basically applications like making API calls to each other, right? So you can use any
I think the question probably is the RESTConf or is some or the whatever the queue
you can drop the conf part. Drop the conf part, and it's going to be the REST or gRPC.
Okay. The gRPC. So
does that mean that both child domain and the parent domain are the same type of controllers?
So for now, yes. So for now, it assumes yes that it's going to be ONOS because we're going to be developing the two-part application or symmetric application that can act in the two different roles will be deployed on two ONOS clusters or in different roles. But long term,
both will be ONOS, but different vendors.
Yes, that's my idea, right? But long term, I mean, if we evolve, once we establish the model for interaction, And we could potentially support the same model over well-published, over well-defined REST API, and then we're completely in open territory where you could have a foo-bar controller running here, and you could have ONOS running here.
What they call it, the GPRC?
GRPC.
Actually, the gRPC is point-to-point, right? So the point-to-point, you in the real deployments, you probably need a multipass to guarantee the HAs between the control domain and this. You're bringing another.
So, I mean, the idea is that when we say an application is running on the child controller, it is running in HA mode, right? And we already have support for running an application. You can. I mean, there are multiple copies of that application running. Just that one instance is acting in active mode. Right? Everyone's in standby. And if I mean, I talked about how events are pushed from the child to the parent. I mean, we can guarantee that these events are not lost even if an instance goes down.
Any mechanism between this control and the child, the parent and child should be guaranteed.
Yeah. But I mean, the specific wire protocol, I mean, it's not very important. I mean, you can use you can write your own thing. But as long as we
But I think if the model, what's key is if the model of interaction becomes successful, clearly we should make sure that we use a fairly accessible wire protocol, so to allow interactions of different or heterogeneous controllers.
There's sort of this other issue that I think he's getting at, which is that you want to make sure that your control connection is reliable. So you can imagine that, well, maybe the control connection and the data connection share the same length. And so if the data connection becomes congested, maybe it causes your control connection to drop or something, which you're in this kind of irritating failure mode where you're getting a DOS attack and you can't shut it off because it breaks your control connection or something.
But it's a similar problem, just at a level higher, right? Like with devices today.
Right, which also probably isn't adequately solved. but it becomes very likely much more likely to happen if you have this interconnection over the LAN, especially sort of a peer-to-peer model, where multiple ASs are using this for peering.
So I think the other thing that I think the sort of the reason behind this slide is, I think as Thomas mentioned, the sort of the way someone can deploy this application doesn't necessarily mean that they have to run like a separate parent controller cluster. What is represented in the hierarchical model here? You can potentially run the parent and the child applications in the same cluster, just that they are now operating in a peer-to-peer mode. So whenever there's an event, you have to notify every other application that is operating in a parent mode. So at that point, instead of just notifying one parent, you are notifying with multiple parents. That is a term that I can use here. Just that you should keep in mind that if you have lots of these and they're all peering with each other, you could run into scaling issues. For a small set of control domains that you want to connect with each other, I mean, peering is also fine.
Yeah, I think you might have different models, just the same way as you have different control software, right? So, you probably want peering in your local cluster. You might even want it in your metro cluster, and you may or may not want peering depending on other considerations in the WAN, like maybe you want it or maybe you want hierarchical, or who knows, maybe even in metro that for scalability, depending on the density of your metro network or your data center, you might want hierarchical. So I think, you might want to mix them.
So another thing is from the implementation point of view. So here is some comments. So the current the question first. So for the current intent framework, can I implement the PCE module into the applications? Can you call the PCE module implemented in the application?
I'm not sure I understand. So right now we're dealing with ESAP on a southbound.
No. It's a path calculation algorithm, right? When you implement the path calculation, basically it's in the modules, right?
Sure. So we can.
I want to implement that one into the application, via application, right?
I think the answer is yes.
So today with ONOS, you can provide your own path service. Sure.
Path service
in addition to the one that the core provides, which is based on all like structureless paths, right? But you
Okay.
can build your own path service.
Okay. So the point is this. So all these are algorithms. Yeah. So far looks good. So the cover the most of the case, right? In the futures, I probably myself can or try some things or doing some things. I build the algorithms myself. I want to install that once as the applications. I hope that one can replace your hook into the intent and replace your current algorithm.
Sure. I mean, it's your cluster. I mean, you can control which path, computation algorithm or service you want to run, right?
Okay, good.
So,
okay.
I mean, clearly, I mean, obviously, when you say that you want an application that will determine what path it will take, your application is more than like a very isolated application. It has deeper control of what.
Oh, I think that probably I want. Okay, so for the intent framework, I don't want the intent framework to tie to a particular algorithms. So that algorithm can be replaceable.
But it isn't today. I mean, it's using path service. What implementation of path service you decide to deploy is your choice. Core provides one. If you don't want that one at all, you have to disable it. But if you want a new one or an alternate one, you can certainly deploy a new one that implements path service. And then the intent framework and everything else that uses path service, we're going to start using that.
Okay.
So that's possible already.
Okay, I think I missed that part.
Which is routing across other intent domains, will make use of path service, which is one. Is that correct?
Well, I'm just saying, today, let's say a lot of the compilers / installers for intents use path service.
Okay.
Which is
you can supply alternate path service today. For when we're doing the macro path computation, that will not be using path service because the path service is on devices, infrastructure devices, and links. The path service we're going to be providing will be for domain-based graph.
Okay.
But there will be an analogous component which you can provide an analogous implementation to be able to control route or path computation across domains if you want.
That sounds like the answer to the question, which is that's another pluggable interface which will be analogous to
path service.
Yeah.
Yep. Okay.
All right.
Yep. Any other questions?
Is there Matteo, do you have any questions, concerns, suggestions?
Yes, if you would like, I would like to present also my approach.
Sure.
I don't have a presentation, but I still have my, let's see.
We have the wiki page projected.
Yes. Do you see the page?
Yes.
Okay, so all this documentation is in the ONOS wiki. As you can see in the feature proposal, you can find the ONOS multi-cluster peering provider. A lot of our approach is similar to Madan's one, but the main difference is that we are taking a peer-to-peer. We are taking a peer-to-peer approach, and in fact, we are also considering a multi-administrative domain scenario. It doesn't mean that the provider is not designed for a single domain scenario, but in our opinion, also it can apply also to a multi-domain administrative domain. So more or less, the architecture that we foresee is that you have the network here is managed by two different administrative domains. The cluster A is an administrative domain. The cluster B is another administrative domain, and these two networks are interconnected. We call interlinks the physical link interconnecting the two administrative domains. Okay, and then we call the customer and edge points the ports where each domain is connected to the customers. I don't want to go too much in detail, but more or less the approach is similar in terms that each cluster is exposed as a single big switch to the other clusters. So for cluster B, the cluster A network is a big switch with 3 interconnection to its cluster plus 2 interconnection to the customer networks, and so on for the cluster B from a point of view of the cluster A. The main difference between our approach and Madan's one is that the big switch comes also with the matrix. So if I'm cluster B, I don't care about the internal topology of cluster A, but I care about the metric that takes me to go from this link to the customer, or to the green link to the same customer, or to the blue link to the customer. So I would like to know which path is the best path for me to go from my customer edge point to the other customer edge point. With this metric, I can compute the best path, suppose the best path, end to end. So if I can go here, more or less the approach is pretty similar. So the customer, so an application running on top of cluster A or on top of cluster B asks for an intent, end-to-end intent, so that spawns over multiple administrative domains. Here, what happens is that we create a new peering provider that interact with the core, but in fact expose the other networks as big switches. So when an application here try to configure this path, in fact, is completely so the complexity of the network is tied to the application, and the application sees the local network plus another big switch. And so, in fact, each application can try to install an intent, a local intent, but in fact, the intent is installed locally by this cluster, and then for the big switch, the intent is sent to this multi-cluster peering provider. The peering provider sends the intent to the other cluster, and this multi-cluster peering provider split this intent to a local intent. I hope it's clear what I try to explain. If you are a bit familiar with Icona, the approach is similar. The difference is that Icona was an application on top of the distributed core, and so was unusable by other applications. So in fact, we are maintaining the same approach, but we are moving from an application to a provider in order to expose the same functionalities that this peer-to-peer approach up to using the core up to all the other applications. Latest thing I want to say is that considering this multi-administrative domain scenario, we want to design this provider as a policy-based routing, not only a shortage-based routing. So what I expect to have here in the provider is the ability to, as the network administrator, to modify the metric exposed by other clusters, or to filter some routes, or to filter the number of intents that are settable by external domains, and so on. So the idea is that, okay, as an administrative domain, I will give all the other administrative domain a way to configure also local intents in my network, but with some restriction. So, for example, the priority of the flows will be different. The number of flows that the other administrative domain can set is limited. The metric is something that is configurable, and so on and so forth. More or less, this is the information that I want to provide to you. The only concern that we have right now regarding the current ONOS behavior is that, for example, if we expose to the ONOS core a big switch, currently is not possible to expose also the internal metric of the big switch. So right now in ONOS, as far as I know, a switch is supposed to interconnect all the ports with a zero metric. We would like, if it's possible, to introduce the ability to configure also the internal parts of a switch, because there are some scenarios, for example, in the optical domain, where you cannot suppose that all the ports can reach all the other ports, but you can have also a subset of ports that can reach other ports. So this is the first thing. And the second thing that is the communication between the clusters. So with Icona, we were using SLCast, because at that point ONOS was using SLCast too. But we were using SLCast because we designed this peer-to-peer approach, thinking about multicast and thinking about an event-based communication channel. So the idea is that each peering provider send a message, an event-based message on the communication cluster, and this communication is received by all the other peering providers, leveraging on multicast. Right now, we don't want to leverage on SLCast again, but this is an open point. The way how the cluster can, how the provider can communicate is an open point right now. So that's all from my side.
Okay. So I think there's a couple of complementary points, like for example, the notion of customer edge points. That's something that we sort of glossed over, but clearly that's something that would be exposed as or would be integral part of the big switch, right? Representation.
I do like that model. I have to say the model of like using a provider to inject.
No, and yes, and I was gonna say that's actually the same to. Yeah, because the big. Not only so there's two constructs here.
It's the same to the in Icona you have two clusters that are peering, right? In our proposal we have a hierarchical model where we represent big switches to the hierarchy to the upstream controller. Whereas here basically your neighboring device appears as a device in your system as a giant switch, and you don't know anything about it.
Sure,
it's kind of cool actually.
No, and so I think it's an area of overlap. The reason we added another level of indirection. So the idea is that with Madan's proposal, which allows for either hierarchical or peering, is it exposes the intent domain, but the intent domain underneath it has a big switch, just like in here. The reason we have the intervening layer intent domain is to give us a higher level abstraction than a device to be able to have interaction with, to be able to engage in that bidding process. That's one thing. That's because the device itself is a big switch, is a useful thing, but it has shortcomings, as Matteo pointed out.
Well, I mean, so here's the thing. So we're making a lot of assumptions about the intent domain. That we have to be honest about, right? Like we're saying a lot of things about the intent domain subsystem when it doesn't actually do anything right now.
The only reason it doesn't do anything right now is because we've been preoccupied doing other stuff.
Fair enough, but the point is that like we're making assumptions about like not only do we make assumptions about the intent domain subsystem doing X, Y, and Z, we're making assumptions about the intent domain system using other applications to do X, Y, and Z.
Okay,
right. So that's a huge.
Forget about the intent domain. Would you agree that the device level abstraction, while nice, it's also at one point it's also too simplistic or another? For example, we don't have changing the model, enhancing the model to add cost function for port-to-port reachability within the device will be non-trivial exercise.
But here's the thing, right? Is that it in a way, right? Like do you? So that's a policy, right? Is that like I have a peering relationship with my neighbor, right? And he exposes himself as a giant entity. Right?
Yes.
He can decide to either hide more information or less information.
Absolutely.
So that gives you the flexibility to now break it up, and you could actually lie to your neighbor, right? And tell him like I have this topology, which actually all it does is represent different levels of QoS. right?
Okay.
Absolutely.
So,
Yes.
you're
And
saying
that's
that
one reason for the event.
So you could by this model, rather than showing just a big switch, if you just show a big switch, then yes, you're limited. But if you show more than a big switch and lie completely, right? And lie completely, because this topology has nothing to do with.
Exactly.
You just say that point A, point B, and then there's interconnections between those with several properties on it.
Yeah.
Done. Problem solved. Right? Like it's up to you what you expose, and you don't even have to expose your internal topology. You can expose some arbitrary topology that exposes the properties you want to expose. Finish.
That is what we can do, right?
Yeah.
I mean, when the child exposes the
I'm not saying we
topology
can.
to the parent.
I'm not saying we can.
Right.
Can and cannot do it. I'm not saying that one model is better than the other. This comment started from like we're making a lot of assumptions. Right?
So there is assumptions we're making.
Based
on our plans
and
for
when I say
domains,
we're making
yes.
a lot of assumptions, I don't mean it as criticism.
No.
I mean it as a fact. Right? Like it's just true. Right now we're making a lot of assumptions. I don't think that's untrue. And the advantage that this model reuses parts of ONOS that already exist, which is kind of nice. Like if you think about it, like all you changed is you added a new provider. That's pretty freaking cool, right? Rather than adding a whole bunch of other code, new code that may be more beneficial. I don't know, right? It could be much more beneficial. I don't have an answer for that.
Our view what Madan proposed and what Madan and I proposed is an enhancement on this. Because I mean we discussed this with Matteo in the summer before ONS, right? So this is basically a continuation on that.
Okay.
And so yes, you're right. So this is maybe it's a little more elaborate, but I think so. And maybe it's making more assumptions, but I think it's a recognition of the fact that the more naive approach, which is just putting a big switch.
But you don't have to. But you realize you don't have to. Right? The fact that they put a big switch is because they decided to put a big switch, but you don't.
No, I understand. That doesn't matter. You can portray it as whatever topology you want. I completely understand.
Matteo's one and this one is against the same problem. Just focus is on the different side of it. This one is more focused on the giving the visibility of the other domain up to or to the neighbor side. And the intent domain stuff is more about delegating the control down to other entity. Now, if we simply do this model,
there is the same thing. Right?
Yeah, no. The problem is that delegation control is not going to be complete with this model. You cannot express intent if the neighbor is only represented as a simple device. It's right. I mean, from rule or those instructions doesn't have the original intention information.
So you're not pushing plurals to him. He's pushing intents to them.
Right.
The intents are being replicated to the remote instance, which is then doing the programming. You're not pushing a
But
plural.
that's in what you just described is an intent domain.
No, it's not.
It is.
No, it's not.
It is.
No.
Yes, it is.
It's not true. That's actually not true.
Remember what the first version of intent domain within the cluster is. We're gonna have one single, just to reduce scope, right? Was move forward with a single domain within a cluster. Basically, there's a control domain equals intent domain. For simplification, so we don't have to go wrapped around the axle, around the pathfinding, and all of that stuff. The key part here, the biggest assumption we're making is on the implementation of a single control domain. The pathfinding stuff is actually the easy stuff. But once we figure out how to make the intent domain work or demonstrate that it works well with different control application providers, whether it's segment routing, optical, or whatever. Once we figure that out, then
the assumption is that these applications will actually implement your intent correctly.
No,
Or
I'm
even implement it for that matter.
understanding. So we're not asking for the native applications to do that. The applications do something. The controller that provides an intent domain controller or provider is not the application alone. It is the application plus something else. We're doing that today. The compilers are the plus something else today, but the compiler dealing with low-level primitives that we decided are not very conducive to reuse of the issues. So yes, we're making assumptions. I'm not disputing that. That's clearly a fact. All I'm simply saying is that, and that basically Jutta said it better, is it's a too low-level primitive. And by saying
what's the too low primitive?
So you're going to be passing, basically you said basically one control domain is going to be passing intents to the other control domain.
Which is
right? To be basically intents to be installed on devices. what you've described here can be mapped, traced to exactly what Madan and Matt proposed.
So in terms of federation, yes.
Yes.
In terms of federation.
Yes.
Right, that I agree.
Sure.
Exactly.
That's fine, that's fine. It's the intent domain part that is the problem.
Okay.
So you mean like multiple intent domains within one?
I mean, even, yeah. I mean, like the whole, like the design of the intent domains or the intent domain.
So
Sure,
how-
okay,
how-
that's a different conversation.
So so this thing is going to have to deal with pathfinding, right? So this thing is going to be dealing with finding of paths between different devices in different domains, right? So if you have more than two control domains here dealing with each other, right?
Yeah.
It's going to produce a topology which spans and includes multiple control domain devices, right? Okay. How are you going to delegate? Are you going to delegate intents for example, you have 3 control domains that span a path. And now you found it internally. You found it as a path because we represent these things as devices. We found it as a path between devices. Great. Now we delegate intent domains. We basically now deposit somebody says, I would like to do a connectivity intent from here to here. Yes. Today's intent framework. How is it going to do that?
We don't have any mechanism by which to do that right now.
Yes, an intent because the intent domain is the mechanism.
Okay, but whatever. I mean, like, no, this is ridiculous, right? Like some magical thing is going to do this. It's not.
It is not a magical thing.
It is.
It is not a magical thing.
It is. Like,
all I'm trying to say, Ali, I understand fully your objections to this.
You don't.
No, I do.
You're dismissing it.
No, I'm not dismissing it. All I'm trying to point out is that you and I are talking about the same thing. You just don't like the intent domain.
You don't want to call it intent domain?
So what do you? I mean,
can we name it something else? I don't want to
no, okay. Basically, like, okay.
We're solving the same problems. We're solving problems of pathfinding and delegating to different authorities.
You're not, right?
Okay.
You're not because you're bumping you're bumping the problem one level higher.
Okay.
Right? So and you're making assumptions on applications that provide services on the network, like segment router.
I think that's where you're wrong because that's not what I'm making assumptions on. And I think so. Again, I'm not saying you're misrepresenting what I'm saying. I'm not saying the naked segment routing is going to provide this. I'm not saying this naked path optical application that we have today is going to provide it. I'm saying path optical plus something will provide ability to implement an inter-domain controller. Yes, I completely agree. It doesn't exist right now. It's fairy dust. And yeah, I'm not saying it's without challenges, but we haven't given it a full go to be able to. It would be too soon to give up. All I'm saying, and I'm basically saying that the way. So what you're suggesting is that we should approach it in a simple manner. Is just pushing the toothpaste to the other end of the tube. We still have the same problems. You're just solving them using a flattened topology today. And you will still have the same problems. You will still solve identical. You will still encounter identical obstacles.
I don't know. I mean, I am not at all convinced by that statement at all because you could solve the problem. Say you have a packet optical network and a segment routed network, right?
Yes. Okay.
Living next to each other. If you have 2 ONOS clusters controlling those 2, right? Why can't you do that?
Well, I mean, I think we're kind of going around in circles here. We're revisiting a lot of the topics the same way, and the point of the original discussion was the federated control. I mean, it sounds like if you squint a little bit, the approach that Matteo is pursuing is very similar to the approach that Madan and Thomas have proposed. And how you call certain things and how exactly you define the interfaces seems to be like some of the details here. But I mean, we're well past the 1 hour mark in the TST meeting, and perhaps if this is a topic that we want to continue to debate, we can bring it up in sort of another form in a later meeting.
Okay. Yeah. No, I agree with that. That's probably good. I mean, because I definitely don't want to dismiss your.
No, it's not that.
We need to definitely hash this out.
I think we're saying a lot of things about the intent domain, and I'm not opposed to the intent domain, even if we call it the intent domain.
Okay. No, I was
kidding. But the point is that like we've said so far, things we've said about the intent domain. It'll be used to implement virtualization. It'll be used to implement federation. It'll be used to solve all the problems we have across different types of networks. That, I'm sorry, but that raised like my bullshit detector is going like haywire here, right? Because I'm just like, well, what is this thing, right? I agree. Maybe it will, and I can be wrong, and I'll freaking eat the carpet. But let's have a simple implementation, right? Let's have an implementation of something. Let's have code, right? If we have code and it demonstrates value, then I'll shut the fuck up and not do anything again. But up to now, it's like a magic bullet to solve 3 problems that we haven't touched on really at all, right?
Fair.
So that's where I'm like,
Fair.
this is BS for me.
Okay. Fair.
And I'm not being mean. I'm not being mean. I'm just saying like, hey, this is not right.
Sure. My claim is that in any of those instances alone, but primarily the intent framework, it has value. And even if it doesn't have value anywhere else, we should invest in it.
That's fine.
That's my viewpoint, because intent framework has severe limitations, as we discussed on a number of occasions in the past.
I think
and it's a way to implement it. I simply pointed out that there is a nice match to intent domains and the federation in the way they behave, but I'm completely willing to accept that even if we were to divorce the 2 bindings from each other, we still need to, though, invest in intent domains.
That's fine, but we also have to agree that the limitations of the intent framework that we have nowadays are by design of the intent framework when we built it the first time around, where we realized that, okay, we have to build something. We have to build this intent framework, and the constructs we put into the intent framework were, we were fully aware that there were 2 cores, and we always talked about how we're going to get primitives, how we going to get to something that's a bit more like a programming language. Right?
Sure.
And we always said we were going to do that, and now it seems to me that like forget that idea, right, and move on to something else which is not clearly defined so far.
Okay, so like Brian said, we should probably hold another meeting separately to discuss that, define it.
Okay.
But I think even if we were to remove the intent domains out of the picture, I still think there's a really good alignment between Mateo's proposal and what this proposes, and it's by accident, right? Because it's
That's true. There is alignment. There is similarity. I think both could benefit from each other. But.
Yeah, and so what we should do is we should probably make sure, because some of this work is going to be needed for ONS, which means that we need to deliver certain elements of this for follow-up. And so we need to make sure we coordinate between Mateo's team and or whoever's going to be working on it, to make sure we make forward progress with that in mind. Okay?
Okay.
All right, that was a lively discussion. Thanks, Madan.
They're my favorite type.
Okay, you can take your fireproof suit off now. All right, thanks everybody. Bye-bye.
Bye-bye, guys.